Question number 7. A beaker containing 600 grams of water is kept boiling by 800-watt heater. If 30% of the thermal energy is lost to the surrounding, find the time needed to boil off the water completely. Let the time needed to be T. The energy released by the heater is P times T. And the energy absorbed by the water during boiling is M LV. Since 30% of the thermal energy released by the heater is lost to surrounding, therefore only 70% of the thermal energy released by the heater is absorbed by the water. Therefore, we have 0.7 times energy released by the heater equal to ml, which is the energy absorbed by the water during boiling. Hence, 0.7 time power is 800 and the time is T equal to mass is 600 gram, which is 0.6 kilogram, times LV, which is 3.34 times 10 to the power 6. The time needed is equal to 3,578 seconds. Question number 8. Peter prepared 0.4 kg hot milk at 85 degrees Celsius for his girlfriend. She refused to drink unless the milk is cooled down to 60 degrees Celsius. Find the minimum number of ice cubes, each of mass 20 grams, at -10 degrees Celsius is needed to add into the milk. First, let the mass of ice cube need to be M. For the hot milk, its temperature drops from 85 degrees Celsius to 60 degrees Celsius. The energy released would be equal to E1 mc delta T, which is equal to 0.4 times 4200 times 85 minus 60. For the ice, the temperature of the ice will change from -10 degrees Celsius to 0 degrees Celsius of ice first, and then change to 0 degree of water next, and change to 60 degrees Celsius of water. It involves 3 stages. Okay, the energy absorbed by the ice in these 3 cases is E2, E3, and E4. Okay, E2 is equal to m C of ice, delta T is equal to 10. E3, the energy absorbed by the ice during the change of state, is equal to mLF. Lastly, for E4, the energy absorbed by the water from 0 degrees Celsius to 60 degrees Celsius is equal to mC of water times 60. Okay, we add these 3 terms together. It's the total energy absorbed by the ice. If there is no energy lost to surrounding during the heat transfer process, we have E1 will be equal to the sum of these 3 energy. Okay, therefore we have this equation. As a result, we substitute the value of Ci and LF into the equation. We will get the mass of ice needed is equal to 0.069 kg. Or equal to 69 grams of ice. Since each ice cube has a mass of 20 grams, therefore we have the number of ice cube equal to 69 over 20, which is about 3.45. Therefore, the minimum number of ice cube required should be equal to 4. Question number 9. A solid of mass m is hit by a heater of power P. The temperature time graph is shown. Sketch and explain on the same graph the new graph if A. The power of the heater is doubled, B. The mass of the solid is doubled. From the graph, during the time interval T1, the solid is being heated, and along AB it is still in solid state. During the time interval T2, the solid is heated to melt. Therefore, along BC, solid and liquid state coexist. From A to B, we have energy supplied by the heater PT1 equal to mc delta T. From B to C, we have the changing of state happen. The power of the heater times the time interval T2 PT2 equal to m times specific latent heat of fusion of the substance. For part A, if the power of the heater is double, that means P becomes 2P. Okay? In this case, since M, C, and delta T is the temperature increases, okay, until the solid melts, okay, the delta T is the temperature rise, which is constant, okay. Therefore, the time T1 will be shortened by 1/2, okay. It becomes T1 over 2. Since the melting point of the solid remains the same, therefore the line along AB would become, okay, and the melting point remains the same, and the time is T1 over 2. For the new graph along BC, since power is double, is 2P, and M, mass, and specific latent heat of fusion LF remain the same. Therefore, the time required to melt all the solid is T2 over 2 instead of T2. Therefore, the new graph along BC will become this one, okay, and time interval is T2 over 2. For part B, the mass of the solid is double. In this case, M becomes 2M from A to B, and also from B to C, M changed to 2M. Okay. From the equation, since P, C, and delta T remains the same, the time to increase the temperature of the substance from point A to its melting point will also be double, which is 2T1. Therefore, the new graph along AB will be like this one, okay, where the time interval, this one is becomes 2T1. Similarly, along BC, and since P and LF is constant, If the mass is double to 2m, the time required to melt all the solid will also be double, which becomes 2T2. Therefore, the graph along BC will become this one, okay, where the time interval becomes 2T2, which is longer than before.